Uh, Good morning, everyone. Thank you for giving me the floor. I'm Azanzi Jiomekong from University of Yaoundé 1 in Cameroon. I'm going to share with you my work during the curation grants. Before I'll talk a bit about me, I'm lecturer and researcher in computer science at the University of Yaoundé 1 in Cameroon. I'm working in the domain of semantic web and particularly on knowledge acquisition for knowledge sources for building ontologies, knowledge graph for integrating in application. I'm using empirical research in software
Selected
engineering.
Microsoft Mark as the default voice.
Pardon? Yes, I'm using action research and case study research in that empirical research in software engineering, and my research is applied in the domain of food, in the domain of health, and in the domain of transportation. Last year, I worked on the curation of some papers on ontology learning, automatic knowledge extraction from data sources such as text for taxonomies, glossaries to build ontologies. And a video for this work was published by TIB. And if you want to know everything on my work, you can go to my ORKG profile. I will see everything on my work. Sorry, it's taking some time to let me. Okay, then after this work, I built some workflow that I am following to work when I'm working with ORKG. It starts with reading some papers. If you want to make some comparison to read papers and use to fit ORKG, I start by reading a set of papers, extract information from this paper, and to compare this information to see in the ORKG platform if there is already a template that can be used to register this information. If yes, you just have to register your paper and use to create some comparison. And if not, you can create a new template by analyzing this information and extracting and identifying properties from this information. Of course, you can validate these properties using the papers that you read and another papers. Then I use this workflow during the second curation grant on the domain of food. Globally, food information can be used for a variety of purposes, such as food recommendation. For example, recommending food to a person who is following a diet plan, and clinical practice, etc. And today I'm going to present I'm going to present the documentation of these three research problems: how knowledge are semantically described, how machine learning techniques are used for food information processing, and how different stakeholders are using food-related knowledge. Then concerning templates, I'll show you some template that I built. Let's start with this template about food composition table description. Then this template is used to register papers on food composition table in general. In food, classify the world, the global world in region, and if you come here in these properties, you can see the different regions that we have: China, Hong Kong, and so on. And each food combination table can also provide the number of ingredients that is in the food, the number of foodstuff, the application that are going to use the application of the food composition table, the name, the number of food component, the number of food group, the purpose of the food composition table, the data set that are used to construct this food composition table, the list of food group, the year of publication, the list of food components, the country, the person or the organization who published this food composition, and the people who can use this food composition table. Then this is another template. Then during the work of curation, you can also improve the work of others. I took the template created by Natalia Shikova that I improved in order to cover food knowledge graph, to cover the description of knowledge graph and ontology in general. Then I just added some additional properties to this template in order to cover this domain. And I was also inspired by, yes, concerning the ontology construction, we are looking for methodology, tools, process that can be used to build ontology in general and ontology, food ontology in particular. Okay, this can take times to come up. I'll continue directly with my presentation by waiting that I open it, but I forget to leave it. Okay. Okay, then concerning the comparison of papers, I use this. I use the template that I created and other template that I didn't present here to compare a set of papers related to food information processing and description. Here, this is about extracting information and describing food information. Then, if I come back here, I will show you the food classification system in general. Food classification system in general are going to classify food depending on their nature, on the place where it is produced, and so on and so forth. And in this comparison, we are going to see the URI of the food composition, of the food classification, the name, the purpose, the reference publication. Then this reference publication is linked to the papers that is describing this food classification and the research program. Also, concerning the food component comparison, you can see that I took five countries: Germany, Italy, Morocco, Japan, and Cameroon. And you will see here the different food composition. For example, here the number of food components that are described in the German food composition database for dietary evaluation in children and adolescents. And here you have the list of food components that we have in this food composition. Here we have more than 35. Here we have more than 19. Concerning the food ontologies construction, I said before, we are seeing the data sources, the evaluation methodology, for example, human evaluation, evaluation using a tool, evaluation using network analysis, etc. Then here we are also presenting how a food composition can be described using the template I presented before. And this comparison, I'm presenting the summary of existing food ontologies. These are the years of publication. And here we have the reference publication, which links to the paper which is describing this food ontology. Then this comparison was taken from a table from tables from these two papers. And here we also have a summary of existing food knowledge graph if they are using an ontology, and if yes, which ontology are they using, the name of the knowledge graph, the reference publication. I got this table from these two papers. Then concerning the use, let's go back to my presentation. Then globally, I can say that food information are processed using machine learning, natural language processing, role techniques, and are classified. And we have four main ways that people are using to describe them. We have the food classification system, the food composition tables, the food ontologies, and the food knowledge graph. Concerning the use of food ontology, of food information, uh, here food information are used for question answering system. And now here is construction. Yes, food information are used for question answering system. For example, this is an example of comparison of uh, of question for of questions that are used to generate to generate question answering that benchmark. You can see here that we have the type of the competency question, which can be conference, which can be comparison, which can be simple competencies questions with data size, the domain, the generated question, which question is generated by this template, for example. This question is generated by this template, the knowledge sources from which that the authors are using to build the question answering benchmark. And once the question answering benchmark is built, machine learning models can use to respond to the question of user. Here I'm comparing back of forth and by the directional attentive memory network for answering competency question in natural language. The data sources are provided here. These links are linked to the data sources. If you click on it, they are going to forward you to the data source that I also described. This is the description of the application. This is the domain, and here this is the evaluation of the different method that I use. If you click on it, you have the F measure of the first one. If you click on this one, you have the F measure of the second one. Then given to different configuration, they are comparing different approach to response to natural to question of user provided in natural language. And here you have the reference publication of these works. And here I am presenting the list of food image dataset also. The fifth information can also be grouped into food image, into food and into dataset. And here I compare food image datasets of, and in machine learning. Once the dataset are built, we can just use machine learning models to evaluate, for example, a calorie from a food image. Generally, people are proposing, for example, to use a mobile phone to take the picture of a food and to use this picture to evaluate the calorie that is contained in this food. And here we are comparing the absolute error calorie, the carbohydrate, the correlation, and so on and so forth. Here we have the link to the data set, the quantity of fat, etc. Okay, I'll come back to my presentation. And for me, my best presentation is this presentation about food composition tables. In fact, this contribution, this comparison is given the different application, the countries, the data set from which the authors built the food composition table, the food components contained in the food composition tables, and so on. But what is interesting is that I discovered in these papers that food composition table change over time. And I have an idea to build a global food composition table that I call Total Corpus. I submitted to SEMTAB challenge organized by International Semantic Web Conference. Fortunately, our work was accepted. We extracted about 60,000 tables on internet and proposed to the organizers, and our work was accepted, and we use during the next challenge. Currently, we are annotating it so that it can be useful during the next SEMTAB challenge. Currently, I'm continuing this an ongoing work. I'm working on food recommendation system, on ingredient substitution, food image recognition, and more. And I cannot finish this work without saying a great thanks to the ORKG team and all the grantees for their comments, for their remarks during our weekly meeting. It was very useful for this work. I say a great thanks to them, and let's say bon appetit for some Cameroonian foods. Thank you.